viewers to this lesson. We are on with the compound interest concept. In our previous lesson, we discussed the step-by-step method and the compound interest formula. In this lesson, we will learn how to manipulate the compound interest formula by determining the other variables in the formula other than the accumulated amount. Specifically, we will learn how to use the formula to find the principal, rate, and interest period. Kindly copy the following questions in your exercise book. Question 1. Determine the principal sum which would amount to Kenya shillings 50,000 after 3 years at 10% per annum compounded annually. Question number 2. James invested a certain amount of money in a financial institution which offered interest at 12% per annum compounded quarterly. If at the end of the 2 years, the sum invested amounted to Kenya shillings 108,600, determine the principal sum. Question number 3. A lady invested Kenya shillings 42,000 for 5 years. If at the end the accumulated amount was shillings 92,420 and the interest was compounded annually, calculate the rate of interest per annum. 4. Mary invested shillings 50,240 in a financial institution at 12% per annum compounded quarterly. If at the end of the investment period the accumulated amount was Kenya shillings 102,621, calculate the period of investment to the nearest years. Now you can pause the video and try the above problems. I hope you tried the examples and we can go through them together. From the compound interest formula, we are able to get the amount, but other than the amount, we can get the other variables, that is P, R, and N. So we can get principal given A, R, and N. We can get rate R given the value of A, value of P, value of N. We can also get the value of interest period N given value of A, value of R, and value of P. The examples, as you will see, will help us understand how we can manipulate the compound interest formula. And so we start with example number 1. In this example, we can see the amount is 50,000 and the period is 3 years and the interest is 10% compounded annually. That means interest is calculated at the end of every year, and that means there will be 3 interest periods within 3 years. So we maintain our value of N as 3, R as 10, and A as 50,000. We bring in these values and substitute into the formula to give us the equation below. 50,000 equals to P into 1 plus 10 over 100 to the power 3. We simplify the right hand side and we have 50,000 equals to P into 1.1 to the power 3. And it's a simple equation in P, so we can get P by dividing both sides by 1.1 to the power 3. And here we are, and we can apply our calculator to get 37,565.74 as the value of the principal P. Right. Example 2, again, is not different from the first one, except for a few variations, as you will see. James invested a certain amount of money in a financial institution which offered interest at 12% per annum compounded quarterly. If at the end of 2 years, the sum invested amounted to shillings 108,600, determine the principal. Now, from the question, we can pick the amount as 108,600, but the rate is not 12% because in 1 year, interest is calculated 4 times, quarterly. So if the rate per annum is 12%, then the rate for every quarter will be 3. That is 12 divided by 4. And the number of interest periods in 1 year, there are 4 interest periods because interest is calculated 4 times. So in 2 years, interest will be calculated 2 times 4, that is 8 times. In 1 year, interest is calculated 4 times. So in 2 years, interest will be calculated 8 times. So we have 8 interest periods, and that is our value of n. We bring these values into the formula, and we have 108,600 equals to P into 1 plus 3 over 100 power 8. And then once again, we simplify the right-hand side. We have P into 1.03 to the power 8. We want the value of P. Straightforward, we divide both sides by 1.03 to the power 8. And so if we apply our calculator, the value of P comes to be 85,729.84. Right. The next example is here, where a lady invested 42,000 for 5 years. If at the end the accumulated amount was Kenya shillings 92,420, if interest was compounded annually, calculate the rate. So in this question, we are given amount, we are given the principal, and interest is compounded annually. So in 5 years, we will have 5 interest periods. So we substitute these values into the formula, and we have this equation here, where now R is unknown. And so we proceed to organize the equation. You divide both sides by 42,000. And so we have 1 plus R over 100 to the power 5 is that 92,420 over 42,000. And that brings us to 1 plus R over 100 to the power 5 equals to 2.2. Now, we remove this power by taking the 5th root of both sides, and that brings us to 1 plus R over 100 equals to 1.1708. We subtract 1 from both sides, and we have R over 100 is 0.1708. Multiplied through by 100, we get our R as 17.08% per annum, and this is rate. You can look through again. Most important is to know how to handle n depending on the number of times interest is calculated, and also how to deal with R. Sometimes you have to change R if like in this question, interest was compounded annually. That means it is done once in a year. Well, I hope you followed, and we can move to the next one. That is example number 4. The fourth example, Mary invested 50,240 in a financial institution at 12% per annum, compounded quarterly. If at the end of investment period, the accumulated amount was shillings 102,621, calculate the period of investment to the nearest years. Okay, we identify the variables which are given in the question. We have A, that is the amount, as 102,621, and the principal is also given as 50,240. Now, interest is compounded quarterly. Interest is compounded quarterly, 12% per annum, but compounded quarterly. That means in 1 year, interest is calculated 4 times. So the rate for every quarter, we divide the annual rate by 4 to get the rate for every quarter, and that gives us 3% for every quarter. And we bring in these values into the formula, and once again we realize that n is unknown, and we go ahead to simplify this equation, and we end up having 1.03 to the power n equals to 102,621 divided by 50,240. And we have a special type of equation, which is an index equation where the unknown is at the power. So to solve this, we introduce logarithms at both sides. That is at this point here. We have log 1.03 to the power n equals to log 2.043. Okay. That is, we introduce logarithms to both sides, and if you apply the law of logarithms, this n will come down, so we have n log 1.03 equals to log 2.043. We require n, so we divide both sides by log 1.03, so our n is log 2.043 divided by log 1.03. You use your calculator and your value of n becomes 24.17. Now what this means is that we have got 24.17 interest periods. From the question, you realize that one interest period is a quarter of a year, that is 3 months. So if one interest period is 3 months, it means therefore that 24.17 interest periods will be equivalent to 72.51 months, which translates to 6.0425 years. But we were required to give our answer to the nearest years, so the correct value is 6 years. So our interest period is 6 years. Okay. So with this, for examples, I hope you are in a better position to attempt any question on compound interest. In our next lesson, which will be a wrap-up, we will take time to go through advanced problems involving the application of the compound interest formula. And so key in this topic is that you need to understand the concepts of simple interest and the concept of compound interest. And we will bring forth special problems advanced in nature, and we will have an opportunity to see how we can apply the concept of simple interest and compound interest. Thank you for now. See you in our next lesson.